Today we're going to be talking about functions and just do a quick introduction to them. Functions are something that it's like a relation that gives every input value an output value, or the way that I like to think about it, every x has a different y. A function is really just an equation. There's special kinds of equations that follow certain rules, and we're going to talk about those rules right now. So there's basically the big rule is that in functions there can't be the same x. You have to have all different x's, and all of those x's can have different y's, or they can have the same y's. But really, the way that you want to think about it is there's a version of many to one or one to many. So if I have a bunch of things and they all go to one item, that's cool. We like that. Super fine. But if I have one thing and it can be a bunch of different things, we don't like that. So in this case, this many to one case, this is a function. And then in this one to many case, this is not a function. The way that you look at that when you're looking through like homework problems and everything, it basically is that all of your x's have to be different in order to be a function. So I'm going to write that down. All x's different. And that is a good thing. If there are some x's that are the same, that's not good, and that means that it's not a function. Not that non-functions are not good. We're just going to think about it that way for this thing because we're talking specifically about functions. So let's go through some examples. And the first example is a table. So we've got okay, so the way that I'm going to look at this, each row in this table is a different xy pair. So like I can read it as -5, -5, -4, -4, 0, -1, 3, -1, and 7, 1. What I'm looking for is that all of the x's are different. So all I have to do is go down that first column of x's, and if they're all different, then it's a function. In this case, they are all different, so I know that this is a function. All right, let's do another example. This one is a graph, so I'm going to try my hardest to draw it out as carefully as I can. So we've got that one. That one, and then that one, and then one more. That one. Okay, so when you're dealing with a graph, there's a couple of things. Option number one is that you could write down all of the coordinate points and kind of put it in a table like that first example, which is totally fine. The other option, which is a lot easier and a lot faster, is using what's called the vertical line test. So the vertical line test just says that if I can draw a vertical line, anywhere on my graph and it only hits 1 point, then it's considered a function. If I draw a vertical line and it hits 2 points, then it's not a function. So let's look. I'm going to just do it with a different color so you can see. But if you notice, you've got 2 points, one right here and one right here, that are both on a vertical line. If I were to draw a vertical line right there, it would hit both of those points. And so what that tells me, because it hits 2 points at once, it is not a function. So no go. All right. Now let's take a look at another example. So this example is a it's called a mapping diagram, but it's super similar to a table. We're going to talk, I'm writing these words domain and range. We're going to definitely talk about these in the next video. So let's see, we've got, okay, so what you're going to do on this is you notice that I drew some lines across the board. It's not necessarily like a coordinate point anymore, like -7, -7, -2, -5, like it was in that table. But now what you're doing is looking at where those lines go. So like for this first -7 up top on that domain, you've got two lines. One goes to the 1 and another goes to the 4, which means that that -7 makes two different coordinate points. Like I could write -7, 1 and -7, 4, because that's what it wants to do. It wants to go to both of those points. And then like the next point with that -2 point goes to the 1, so it'd be -2, 1. Then the 0 goes to the -7, so it'd be 0, -7. And then the last thing, the 7, goes to the -5, so it'll be 7, -5. So obviously I just wrote out all the points, which you definitely can do, and then you can determine if all of the x's are different, like we've talked about. But the other option is to say, well, if you've got two arrows coming out of one x, so let me backtrack and say this. Domains are x's and ranges are y's. So if you've got two lines coming out of one x, that means that you're going to have two x's with, or the same x with two different y's, which is not okay. That's one of those one-to-many situations, which we don't like. So because we have that, and the other, because we've written them out and you've got two points that both have a -7 on them, that just means that it's not a function, because you've got too many x, or the same x on too many points. Okay, let's just go through one more example. So this example is also a graph. I'm not going to be as careful with it because it's a line. So it kind of looks like that. And I'm going to draw it in a different color so you can kind of see the difference. But, so here's our graph. And especially when you have a graph that's a solid line, not just points, you want to use that vertical line test again. So if I were to draw a vertical line anywhere on this graph, how many times would it hit the red line? Well, it's only going to hit it once. There's nowhere on this graph that it'll kind of curve around or hit it twice, which automatically means that this is considered a function. So there we go. And there you have it.